Let's take a look at an example that you can find in your textbook. We'll take a look at exercise 5 and then we'll take a look at exercise 9. This is on page 196. So we are given some information here about how water freezes and boils. So we're told that water freezes at 0 degrees Celsius, which is the same thing as 32 degrees Fahrenheit. But water also boils at 100 degrees Celsius, which is the same as 212 degrees Fahrenheit. So what we want to do is we want to use this information that we're given about freezing and boiling points to find a formula that expresses the Celsius temperature as a linear function of Fahrenheit. So basically what we're trying to do is we're trying to come up with a formula so that if we knew the temperature in degrees Fahrenheit, then we could use the formula to figure out what the temperature would be in Celsius. Okay, so we're told that the relationship between Celsius and Fahrenheit is linear. So anytime you're reading a problem where you're told that the function is linear, immediately I want you to think of the general equation y equals mx plus b, because this is the general formula for a linear function. Okay, so that's the first thing. The second thing is, anytime we're given information, you want to convert the information that you're given into ordered pairs or points. So here, we're asked to write a formula that expresses Celsius as a function of Fahrenheit. So that means Celsius is our output, so I'll call y C, and C is related to F, which is the degrees in Fahrenheit, by some m times, and instead of x, I'm going to replace x with F, which represents the degrees in Fahrenheit, plus some b, okay? All right, so ultimately we're trying to come up with some equation for C, and this is the relationship because we're told that it is linear. Okay, so if F is like our x and C is like our y, we want to find some ordered pair so that it's C comma F. And the reason why we're looking for ordered pairs or points is because from these points, then we can calculate the slope and then also the y-intercept. Okay, so let's go to the problem and let's see if we can find our 2 points. And again, I'm saying 2 points because we only need 2 points to calculate the slope of a line. So when water is 0 degrees Celsius, we are told that that's the same thing as 32 degrees Fahrenheit. So there's our first point. And then let's see where we can get our second point. We're told that water also boils at 100 degrees Celsius, which is the same thing as 212 degrees Fahrenheit. So I've got 2 points here. I'll call this x sub 1, and this is y sub 1, and let's call this x sub 2 and y sub 2, so that now we can use the formula for calculating the slope to find out what the slope of this function would be. Okay, so recall that the formula for slope is always some y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. And now let's do the appropriate substitutions. So I've got 212 minus 32 divided by 100 minus 0. I'm going to put parentheses around my numerator and my denominator and go to my calculator and just type this all in as one sentence. Okay? Oops, let's see if I can. Okay, so I'm going to type in 212 minus 32, divide that quantity by 100 minus 0. Okay, so this tells us that we have a slope of 1.8. Okay, so this is 1.8 is my slope. So far we're already getting the formula, 1.8 Fahrenheit plus B. Okay, now our next goal is to try to solve for B. So remember that B represents the y-intercept, and so it is the y value when x is 0. And notice that we actually already have that point. So we actually have the y-intercept right here. When x is 0, y is 32. So I actually don't have to do any algebra to calculate the y-intercept. I actually have it from this point right here. So let's go ahead and substitute that in for B. And that gives us a really beautiful formula for Celsius as a function of Fahrenheit. So there is our linear function. Okay, great. Now that we have the formula, let's move on and see what the next question is. It says, what is the slope of the function that you found in part A, and explain its meaning in practical terms? Okay, so let's go back to part A where we calculated the slope. Now remember, the slope is the change in y, so I'm just going to use this notation. It's the change in y over the change in x. But remember, y in this problem is degrees Fahrenheit. So really the change in the numerator represents the change in degrees Fahrenheit, and the denominator is the change in degrees Celsius. So when we calculated 1.8, I'm going to write this as a fraction by rewriting that over 1. So what this is telling us is that every time the temperature increases by 1 degree Celsius, okay, the temperature is increasing by 1.8 degrees Fahrenheit. So that's what the slope means in practical terms. It says that for every one, so in practical terms, the slope tells us that for every 1 degree Celsius increase, hold on, let me reword this. For every increase of 1 degree Celsius, the temperature increases by 1.8 degrees Fahrenheit. Okay? All right. We'll skip question C for now because you haven't actually taken your exam yet. All right. And we'll do exercise 9 in the next video. But I hope that you are able to see how, from a word problem, we were able to write a linear function based on 2 points.